Hi, Elizabeth. It's just you and me today. I don't know where everybody else is.
That's odd.
I'm good. I'm sure they're coming.
Yeah. So I had a question about the Canvas portion. To review for it, would you say it's just best to go back through the material of the modules?
That's a really good way to do it. Did you see the midterm review sheet?
I saw the oral portion.
Let me find it.
Couldn't find. Yeah, I never saw.
I thought I put it in that same document, but let me look. Hold on one second.
Okay.
Okay, Elizabeth, I put it in the chat. Did you see it?
Yeah, I can see it.
Okay. All right, so let me start off by saying the internet has been kooky today. Anyone have been having problems at their house? Like, I don't think I've been having problems at my house. Like, I haven't been kicked out, but lots of my students have been getting kicked out and coming back in. So yeah, thank you. There must be something going on. Like everybody decided to work online near my house today or something. I don't know. But so if you get kicked out, just come back, right? It's fine. Like maybe Natalie got kicked out already and had to come back. So it's a crazy day, but it's okay. We'll be flexible. We can make it happen. Elizabeth was asking about the review sheet, and so I put it in the chat. If you didn't get it because you weren't here yet, I can put it in the chat again. Yeah, so it's weird that sometimes we have a lot of difficulty and sometimes we don't, because we haven't had any problems so far, but I think it's definitely the internet. So hopefully that link comes through fine on that one. You already had access to it. Maybe it got lost in your abyss somewhere, maybe. I just want to talk about a couple of things, and then we're going to start talking about multiplication and division. Remember, we started our addition and subtraction yesterday with your homework, but that homework assignment isn't due until Monday. So hopefully don't forget about it and forget to upload it. But you should be close-ish to done with it, I'm guessing, right? So just make sure you don't put that on the back burner and it disappears forever. I know how that goes. Two things I want to talk to you about today. Speaking of Wi-Fi issues. So the first one is when we can get back on campus. I don't know how many of you have ever looked at the art exhibits around campus, but there are a lot of them. I don't know why it did that. Hold on, go away. No, I do not want that to happen. There we go. Okay, so there's a bunch of art exhibits on campus. If you are into art, now don't go to campus right now. Right now, you're just going to look at it virtually. But I think most of you know that along the north side of the campus is the Rose Garden. But then look at all those blue dots represent art exhibits, installations that are on our campus. So what you can do right now, since some of you can't go back to campus right now, is you can look through them virtually. Some of them are going to seem familiar to you, and some of them you might not have ever seen. So this is a good way to go, oh, when I get back on campus, I need to check some of this stuff out. There are some really awesome things. A lot of it's created by MCC students. A couple of my favorites are the single hex star, the single helix, and the double helix. Those are right outside my building, so I really like those and I see them a lot. Then the one on the far left was created with the help of one of our math faculty, and they did so much work on that. It's awesome. And so Madeline Chowdhury, if you'll notice her name is on here a bunch, she's done a bunch of projects on campus relating math to other things, and it could be a cultural or it could be, you know, something else that she's done, but it's amazing and she's a great instructor. My favorite is probably this Generations mural. I park in the covered parking, and so I walk by this almost every day when I'm on campus. By the way, I haven't been there since March, just in case you're wondering. And so, but it's a beautiful mural, very colorful, and I just love it. It makes me happy when I walk by it and I just see something new in it all the time. But there is so much stuff. If you've never seen these things on campus, you should read through these things and see and think about where they might be located, so you could get see our campus really, it has a lot of beauty on it, believe it or not. The other thing is, I know that we were just talking about sometimes we have computer issues or things like that. If you know you have some big thing coming up, maybe it's your final exam, maybe it's, you know, a big project that's due and you're worried that your Wi-Fi is going to screw up, you can reserve space on campus for this. It's you're limited to 2 90-minute sessions per day, and you have to wear a face mask, but you can see where it's located. It is only on Monday through Friday. I wish they had availability on Saturday and Sunday, but at least this might give you some access that you really need in a pinch. All right, so that's our Thunderbird Thursday. I did want to bring up that part of being a college student is studying with others. And you guys, I know you got group chats going on. I know you got a bunch of stuff going on, which is awesome. But you probably want to make it somehow on a consistent basis. Like maybe you plan a Google Meet or a Google Hangout or a Zoom that's every week at whatever day, at whatever time that works for you guys, so you could get together. I really think that's the best way for you guys to learn besides coming to see me. The tutoring center is great, but we have some issues. Oh, good. Sydney said that's what her, Amy, and Kristen do. Other people probably want to get on that bandwagon. I didn't even know what I was going to say for a minute there. So, but You guys have some outstanding classmates. Everybody in this class is going to be a great teacher if that's what they choose to do, right? We still have some people who are like, oh, maybe this is not for me now. But you guys have some great examples. A couple students in here had excellent Farmer Hank problems from the very beginning. I think it was Hwan's and Shitong's, and there was one other one. And I put a comment in your thing that said, can I share this with the class? If you don't respond to me, I won't share it. But some of you doubt your abilities and you're actually way better than you realize. So make sure you're starting to talk to each other because it's that type of thing that's going to improve all of you. Excellent. So this is what I want you to do right now. Here's your problem. -4 minus 2. And you're like, boom, I got this. I know the answer. That we all didn't doubt that. You got in this class for a reason. You passed the prereq. This is what we're going to do. We're going to use the takeaway strategy, and I want you to walk through it step by step by step. I'm going to put you in breakout rooms with one other person, and you're going to use a whiteboard or something so you can outline those steps. If you want to use the virtual manipulative and screenshot, you can, but you should have a step and a picture for each part. Yes? I'm going to give you about, I don't know, maybe 5 minutes and see how you're doing. Okay? So has everybody got the question? You know what you need to do? Okay, so I want you to do it's -4 minus 2, and I want you to do it step by step. Okay, so go for it. I think one room has 3 in it, but you'll be fine. If you don't know the person in your room, make a new friend, okay? Okay, and I'll pop in and visit. Let me know if you need me. Hello, hello. Not everybody's back yet. You still have 30 seconds, but I want you to think really hard. Who is going to want to share first? I know it's exciting and I know you can't even wait to share. Who's it going to be? I should have my wheel. You know what I'm going to do? Instead of that electronic one, I'm going to make a big old wheel and put it on my wall behind me and like spin it so you guys can see it. Yeah, it's going to happen. Maybe I'll pay my kid to do it. He'll do anything for money, which is a little terrifying.
I have a family friend who's a second grade teacher right now, I believe. And she lives in a trailer, but her whole trailer has all her teaching stuff in it. Like I don't know, like the pockets to make a calendar and stuff.
Nice. I think you would have to do that. Okay, so I'm ready. Which team wants to share? It's your opportunity right here.
I'll show my work.
All right, Elizabeth, I'm ready. Thank you.
Can I put a screenshot in the chat?
Yes, you can.
I screenshotted my work.
Yeah, you should be able to put it in the chat and then I can pull it up or you can pull it up, either way.
Okay, let me do that.
Natalie, you look like you're like by a windy ocean. You look like you're ready for a photo shoot. What's happening? Is there a fan on?
Yeah, it feels good.
I know I have a fan on too. I don't know if it sounds like a train wreck in my room, but there's a fan over here because I feel like it's extra hot today.
Okay, yeah, I like to have my window open, so.
Elizabeth, I see it now. Okay, it's downloading. I'm opening. Okay. So, do you want me to share it?
Yes, please.
Okay.
So,
there you go.
Yeah. For this problem, what I did, as you can see, I drew out 6 negatives to represent the -4 and -2. But I also added 2 0 pairs because that's how I thought about it, was by adding 2 0 pairs, it just kind of made more sense to me. But yeah.
All right. So maybe we need some steps labeled there, but good job. I'm glad you shared your stuff. All right. Who else is going to share? We're just going to compare some of these so we can see.
I can share.
All right. I'm ready, Gabriella.
Okay.
So we have Elizabeth that we saw where she modeled -4 and -2, and then she added 2 0 pairs. And now Gabriella is going to share. Yes?
Yes.
All right.
Can everybody see that?
Yep.
Okay. So right here are steps. So we started with right here, the 4 negative chips, and then we added 2 0 pairs, and then we took away the 2 positive, and then we were left with the 6 negatives.
All right, so it's similar to Elizabeth's, but now we have a little more detail, right? We just started with -4 chips with Gabriella, and then we added 0 pairs, and then we took away the 2 positive chips, and we're left with 6 negative chips. All right, so you can kind of see the difference. Excellent. All right, who's going to share next?
I can share.
I'm ready.
I don't know if it's reversed for you guys, but
nope, it should be fine.
Okay, I just put the 4 negatives and then added 2 0 pairs, took away the 2 positives, and then added the rest at the end.
Okay, nice. So that's very clear. By the way, if Abigail is sharing like that, I don't know how you guys have your screen set up, but when I set it to speaker view, then Abigail is big instead of gallery view, so then I can see the whiteboard really well. Did everybody do that? Abigail, hold up your board one more time just so we can see it. If you want to screenshot someone else's, you totally can. Like, it's fair game. I'm going to record it, obviously, but I'm just saying.
Yeah, there we go.
Okay, good job. So this is very similar to Gabriella's. It's just what I like about it is it was very clear. Step 1, step 2, step 3, step 4. What I would add is words by each one. Like Gabriella had words and pictures. So add some words there. Who else is going to share?
I'll do it.
All right, I'm ready, Kristen.
1 second. can you see that?
Yep, we can.
So step 1, we model the minuends. We draw 4 negatives, and then we added 2 0 pairs right here, and then take away the 2 positives, and then count the negatives. You have -6.
We added after you came in, then we added the steps where it says model the minuend, and then add the 0 pairs, take away the 2 positives, and then count the negatives that are left over to get -6.
That's awesome that you just had pictures at first.
Yeah.
And then I said, add your steps. So good job. Excellent. So this is very similar to Abigail's, and I can't remember who Abigail's partner was, and Gabriella. And then now remember Elizabeth. Elizabeth modeled both the minuend and the subtrahend. So we need to think about when we want to do that and when we don't. All right, good. Anyone else? Last call for sharing this. All right, so the only way you get good at this is if you practice, just so you know. So you have to practice this. Now I'm going to show you mine. Here's my steps. Model the minuend, and I just screenshotted the virtual manipulatives. And notice that none of you added this part, which is important because it shows your thinking. I need to take away 2 positive chips, but I don't have any. That's why I'm adding the 0 pairs. So you should all add in your reason why we're adding those 0 pairs. Now I can take away 2 positive or yellow chips, and I put a little note on the side and I scratched them out so we could see. And now the last step is we're going to count the remaining chips. So do you see how structured mine is? So that's what yours should be. And by the way, this is a great question for the final exam. It's not on your midterm because some of you are even done with your midterm already, at least the oral part. Any questions on this? All right. So I sent you 2 handouts, yes, yesterday? One of them, it looks like this, patterns in multiplying integers. So if you have that with you, you can have it out. If you just want to follow along, we're going to kind of do this together. So I'm going to start it and then I'm going to set you to your own. So we're going to talk about multiplying and dividing. So first, we're looking at these problems 1 and 2. So notice that it says complete by filling out the products you know, then look for patterns to fill the missing entries. So what I want us to do is, it was given to me that 4 times 3 equals 12. I know that 4 times 2 equals 8. I also know that 4 times 1 equals 4. Stop there. Don't think anymore about the math, about like the multiplication. I only want you to think about the patterns. Okay, so this kind of goes back to like week 1 when we talked about patterns. So think about patterns. If we look down this column, what do you think those next 3 blanks would be?
4.
Yeah, they're going to be 4s because my pattern is 4, 4, 4, 4, 4. So that's my pattern. So I'm just going to add those 4s. Now look at this second column. Do you notice it goes 3, 2, 1? What do you think's next?
0.
0, then
-1.
-1, -2, -3, -4. Excellent. So now I repeat, I do not want you doing the math. I know that sounds really weird for your math teacher to say, but I don't want you doing the math. I want you following the pattern. So let's look at this third column here. 12, 8, 4. What's happening there?
Subtracting 4.
Yeah, it's going down by 4 every time. From here to here, we went subtract 4. From here to here, we subtracted 4. So if that pattern is going to continue, I'm just going to keep going. So what's 4 minus 4?
0.
0. Thank you, Anaka. 0 minus 4?
-4.
-4. Then what?
-8.
Keep going.
-12.
Keep going.
-16.
Nice. All right. Now, we weren't doing any math. We were just doing like patterns, right? I wasn't thinking about multiplication. All right, so leave that for a second. Now I want you to do this one right here. Now we're going to follow the same strategy right here. This second column, these are all fives, right? So I'm just going to go 5, 5, 5, no problem. This time something's happening here. So it says 4 times 5 is 20, 3 times 5 is 15. What number do you think goes right here?
2.
2. Now, I don't want you to do any more math. I just want you to follow the pattern. So go down the column. Okay, so fill in these and fill in these. And I'll give you about, I don't know, 20 whole seconds to do it.
When I was doing the more homework last night, there were like simple problems like these and then more in depth. I felt like I was getting the more in depth ones like super fast, but once it came to like 7 times something, I think I was just going so fast and I would miss them. And I was like, how am I missing these when these are so easy? But the more in depth ones I was able to get, it was always the really easy ones, like a 4 times 3 is like the different path. It was when I was getting so frustrated. I was like, how?
Maybe you were just concentrating on the in-depth ones, right? And just kind of rushing through the easy ones and making silly mistakes. All right, so if we go down this, we're going to get 1, 0, -1, -2, -3. And over here, our pattern was subtract 5. So we're going to get 5, 0, -5, -10, -15. We didn't do any math there. We just really looked at patterns. You know, I shouldn't say we didn't do any math. I should say we didn't do any multiplication there, right? Except for the ones we already knew, which were our positive numbers. So now I want you using this information here, not using your previous knowledge, just using this information here. Write a rule for multiplying a positive number and a negative number. Okay. All right, so what is your rule that you wrote?
If you multiply a positive and a negative number, the answer will be negative unless it is 0.
Very nice. So when we multiply a positive number and a negative number, our product is always going to be negative, yes? So, and I didn't even think we needed that 0 disclaimer on there. I'm not saying it's bad. I'm just saying I'm not sure it was necessary because 0 is not positive or negative, right? So when we're just talking about a positive and a negative number, we're only going to look at these down here. Okay, so I noticed it didn't matter if the negative value was the first factor or the second factor. My product was still negative. Is everybody all right? And you see where it came from just from our patterns, right? And you're like, we already knew this, but you never saw where it came from. And that's what we're talking about. Okay, so now down here, you're going to do the same type of thing, but now notice what we're saying. We're saying, okay, now you believe the rule. You believe the rule from questions 1 and 2 that you just developed that said a negative times a positive is a negative, or if one of the factors is negative and the other factor is positive, then the answer or the product must be negative. So now we're going to continue following patterns and we're going to say, ooh, now I'm writing in highlighter. That was super fun. Now we're going to say -3, -3. You fill in all these, and then do the same thing over here on number 4. When you're done, I want you to write your rule for multiplying 2 negative numbers. So go ahead and fill in that just using patterns. Don't do the multiplication. All right. So somebody fill in all these blanks for me right here, starting at under the 210.
-1, -2, -3, and -4.
Excellent. And then under this last column?
-3, 0, 3, 6, 9, 12.
Yeah. What was the pattern right here that was happening?
For under the -6,
Yeah.
you were going up or adding on by 3.
Very nice. Adding 3. Very nice. All right. So on number 4, somebody tell me what goes right here in this whole column.
It's 2, 1, 0, negative 1, negative 2, negative 3.
Very nice. And in the second column, that's the easy one, right?
18.
Wait, this one right here. Just -6s, right? In that middle column?
Yes, yes, -6.
All right. And now you're ready for that last column, Tintu. This was -18.
Next 0, 6, 12, 18.
Very nice. Now, what was the pattern that was happening here?
So you're subtracting 6 and adding 2.
Subtracting 6 or adding 6?
Adding 6.
Okay. All right. So now what's the rule for multiplying two negative numbers?
2 negatives. Multiplying 2 negatives will give you a positive product.
Yeah, always, right? When both factors are negative, my product will be positive. Excellent. Now, what's interesting about this is nothing new. You knew all this, right? But what you might not have realized is where it came from or why it had to be. Some of you asked your teachers, why is it that a negative times a negative is a positive? And your teacher said, because, right? And so then you're like, oh, okay, so 2 wrongs make a right, right? And your teacher's like, oh, well, no, that's not really true, right? So you have to be careful, but one of the ways you can show students that it must be true is because our number system is all based on patterns. If you started at the very beginning, we talked about place values and our bases and all of that. And so there's patterns throughout that you will notice if you look at them. And right here in this second part, first of all, you have to believe that a negative times a positive is a negative. And then if you follow patterns, right here is the key where it made that shift. Because now we have a negative times a negative, and following patterns, my answers became positive. If they didn't, my pattern wouldn't hold true. Yes? And then the only reason we did number 4 was so we could show that it doesn't matter if the first factor is negative or the second factor is negative, but still we get the same idea. When we end up multiplying 2 negative factors, we get a positive product. Okay, so this isn't necessarily a mathematical proof of why, but it's definitely a better explanation than you've probably gotten in the past. So, and this is something that's very simple. If you can imagine, like 6th graders start developing negative numbers, in 6th grade, they could definitely do this activity, right? Where they're following patterns. So there's no worries about if it's too hard for them. We can also think about it using numbers and number lines. So do you remember when we said that 3 times 5 was 3 copies or 3 groups? Do you remember that? Okay, so if we do that, we can say, okay, the number of groups is 3. The number in each group is 5. And let's look at it on this number line. If we're doing 3 copies of positive 5, we're going to start here at 0, and we're going to say there's 1 copy, there's another copy, and there's our 3rd copy. So we can see our answer. Repeated addition works for multiplication. Even when they're both positive, we're fine. So our product is 15, right? Is everybody okay with that? You could also do it with chips like we just did. So there's one group of 5. There's another group of 5. There's another group of 5. So 3 copies of positive 5 is going to be positive 15. Nice. Okay. What about this? Try this one and see if you can explain it and draw it on your number line. You should have this still on one of your worksheets that says multiplying integers using a number line. Do you have that worksheet? Yeah, so you have that. You can write it on there, or you can just write it on paper. Either way. So try that, and we'll talk about it in just a sec. All right, who's going to explain this to me? I've heard some new voices today, but I would love to hear some more. Some of you who like to talk, I appreciate you, and I know I can see it on your faces that it's killing you to be quiet right now. But you're doing a great job at letting other people volunteer. So I can just start calling on people. Sophia, why don't you explain this one to me?
Okay, so I used the
Integer chips.
Thank you.
Yeah.
And I did 3 groups of -5.
Okay.
But I would do the chips in little tiny groups and do 5 chips, a little space, 5 chips, and then another little space and 5 chips.
Excellent. And so what was your answer, Sophia?
-15.
Very nice. And so 3 copies or 3 groups of -5 is going to give you -15. Great job, Sophia. Can anyone describe how I would do it on the number line?
So we will make 3 groups on the opposite side of 0.
Very nice. There's 1 copy. There's 1 copy. No, now I did something very interesting that some of you might be writing differently in your notebook. Did anyone write, like right here, 1 copy, and then they wrote here 2 copies, and then they wrote here 3 copies? There's a very specific reason I didn't do that, because the size of that little hop is still only -5. So don't write that, even though from here to here, I'm at 2 copies. But when I'm measuring those hops and labeling those hops, I only want to label it 1 copy, right?
Do we label it 1 copy, not just copy?
It's either way you want.
Okay.
You're fine. If you wrote copy, I'm assuming there's 1. So good job. Excellent. So you can see it on a number line. You can see it with the chips. Is everybody okay? Now, this is where it gets a little bit trickier. Let's talk about this one, because if we're just reading it like it stands, we would read this as -3 copies of 5. That doesn't sound good, does it? -3 copies of 5. That sounds bad.
It would be 5 copies of -3.
Oh, so Elizabeth wants to do this. 5 copies of -3. Can somebody say what property allows me to flip those two?
Commutative property.
Yeah, the commutative property. Excellent. The commutative property allows me to do that. I can totally do that. But let's say there's a kid who's really stubborn that says, no, I want to do it in this order. See if you could think of this. Is this okay? And what would that mean in a picture? Do you see what I did?
Would it just be still 3 groups of 5 and you just distribute it?
So how would we read that sign out front? Think about what we talked about the other day with the language of integers. How could I read it to where it might help me make sense of it?
The opposite.
Opposite of
Oh, the opposite. So this way is the opposite of 3 copies of 5, right? So let's look at that. And by the way, Elizabeth's way right here is totally valid. And you will have kids in your class that are like, perfect, I'm just going to change the order and I'm good. And then I can model it, right? So no worries on that. So this is how I would model this part when I'm doing 3 copies of 5, but then I'm going to do the opposite. So how I would do it on the number line is I would do 3 copies of 5. 1, oh boy, maybe I should at least get to 5, right? So 1, that's 1 copy. Here's 2 copies. Here's my 3rd copy. Now, how would I show it visually on the number line to take the opposite of it? What would I do?
Would you just do your copies into the negative?
Well, I already did my copies into the positive. So now I just want to take the opposite of 15. How would I take the opposite of 15? That would be my answer.
direction?
Yeah, in the other direction. Perfect. So my answer to the opposite of 3 copies of 15 is -15. And so how would you show that, like with your picture? It depends on if you're doing it Elizabeth's way, like this, then you can just do 5 copies of -3. And you just have to be able to state that you use the commutative property to change the order. If a kid can tell me that, then I'm going to let them be valid in their doing it. If they can't tell me what property, then I'm not going to let them do it that way. Okay, so same thing with here. If you want to do it this way, you can do the opposite of 3 copies of 5. So you'd have +5 3 times, right? Copies. And then you would say, take the opposite, which taking the opposite would just turn all of these into, these are all yellow chips. It would turn them all into red chips. So if you can imagine, oh, why am I doing so many? I got a little carried away drawing my lines. They were so fun. You could imagine kids with actual chips modeling it like this. They would do 3 copies of 5, and then you would say, now how would you take the opposite? And they would literally flip them all over. So they would make that connection. Okay? Questions on this one? I know this is a little messy. I don't love integer chips for multiplication, and I do not use them at all for division, and we'll talk about that in just a minute. Any questions here? Are you okay? Okay. What do you want to do with this one? Think of a strategy to do -3 times -5. So think about that. I'm going to give you about a minute to figure out your strategy on your own, right? And then we'll talk about it. We just talked about a little strategy we could use. All right. Is there any brave soul who wants to tell me? I know some of you are sitting like this, just waiting because you don't want to do it and then have to erase it because you did it wrong. That's not the way this class works, right?
I can
Mistakes are the best part, right? Okay, go ahead. Who's going to tell me?
I can try it.
Okay, let's try it. I'm ready. I'm so happy you're so brave.
I might be doing this like way too much thinking about it, but what I would use division and divide by -1 or 1, and to bring the negative on the outside, and then that way I'd just do 3 times 5 and get 15, and then do the opposite of that. But that
Okay,
could be too complicated.
so I'm following you, but I have to figure out how we can write it. So you want to pull one of the negatives out front, right? Okay, so like if I take this negative and pull it out front here,
Mm,
then I would say negative, and then I would say the opposite of 3 times -5.
mm,
Does that make sense?
yeah.
Okay, so now how would I show that on a number line? The opposite of 3 copies of -5.
You do -5, or you'd go to the left, and so you do -5, -5, -5 to get to -15, and then you would take the opposite of that and go the other way.
Perfect. So now you're going to take the opposite and you end up at +15. So 3 groups of -5, and then we're going to take the opposite. So here's our 3 groups of -5. And now take the opposite. So they turn all positive. Did anyone else have a different strategy?
Yeah.
Yeah,
I
I'm
have
ready. Juan.
another, because we know the rule of applying integers, if we have the same sign for the factors, then we will get a positive number at the end. So we can use 3 multiplies 5 equals 15. So we get a positive number on the number line.
Okay, so you would just be writing your rule right here that I know that 2 factors that are negative will produce a positive result. So you'll get the same answer as 3 copies of 5. So then you just modeled 3 copies of 5.
Yes.
Yep, you can totally do that. You just need that explanation there. Okay, excellent. Anything else? So I know that some of you, and I've heard it from my online students as well, are like, this has been ridiculous that we're overthinking this, that we have to write all of this down. But I think some of you are now just coming to the realization that, oh, maybe it is helpful because then it's foundational for the future. If you're not quite there, I hope you are. Now, I just said I don't really like the chip model or the number line model for division. With positive values, it's fine, right? So the dividend in this case is 12. The divisor is the group size, 4. So represent the dividend and circle the divisor size groups. So if we have the dividend, we have 12 positives. And then it says circle divisor size groups. So there's 1 group, 2 groups, 3 groups, right? So 12 divided by 4 must be 3, which we already knew because it was positive. And we could show it on a number line. We would say if we have 12, if we are here at 12 and we want to split this into groups of 4, we could just go 1, 2, 3, 4, put a line, 1, 2, 3, 4, put a line, and then we could count how many copies we have. We have 1 copy, 1 copy, and then 1 copy. So we have a total of 3 copies. So it works fine when they're both positive, right? And you could picture your integer chips and do it, and it wouldn't be too traumatizing. it's actually not even too terrible when they're both negative, right? Except for if you want to think of -4 size groups that are size -4, that's okay right now, because if we have our dividend as -12 and our divisor is -4, so here's my -12, and I want my groups to be -4 in size. So again, I have 1, 2, 3. So I'm fine. I'm not saying I love it, but I'm saying it's not too terrible right here. So -12 divided by -4 is +3. So we have -12, and we're going to split this into groups of size 4. And we have one group or one copy, and one copy. So it's not bad. I'm not saying I love it. I'm not saying I hate it, but there is a flaw very soon. And you'll see the flaw. Well, you're going to skip this for a second. Let's see the flaw right here. When you try, I have a video link here that explains, it's a group of teachers that are in a problem and are in a workshop, and they do something like, I don't even remember the problem that's in the video, but what if they did this? 12 divided by -4. Now they have chips, +12 chips. And they want them to put them in groups of size -4. But that doesn't exist. So they're going to have trouble doing that, right? Or the reverse of this. What if they have -12 divided by +4? So they have -12 things, and they want to put them in groups of size 4, but I don't have +4. I only have negatives. So this model falls apart with integer chips. It doesn't work with integer chips. It works in patterns like we've been doing. So we're okay with the patterns. What I want to do now is I want to go back to these patterns, and I want you to practice. This is going to be a flashback. This is a great study for your midterm, right? I want you to multiply 14 by 23 any way you want, right? So a non-traditional way. Don't do it this way, 14 times 23. Don't do it like this, right? That's a no-go. Don't do it like this. So any non-traditional way. And then we're going to do the rest of the problems on the sheet so we can see what's happening. All right, so who wants to share how they did 14 times 23 non-traditionally? If somebody's talking, I can't hear you.
I can share.
Okay, Abigail, I'm ready.
I use the area model.
Okay.
Your box. And on the side, I put 10 and 4. And up top, I did 20 and 3. So then I had 200, 30, 80, and 12, and then added them up to get 322.
Very nice. So now if you notice on your worksheet, I have 3 problems after that that are -14 times 23, 14 times -23, and then -14 times -23. if you show kids that they don't have to do the multiplication again, it's very important. It's very empowering. You'd be amazed at how many times I've gone over this with students and they do this and then they see this problem, negative 14 times 23, and they literally start going like this again. And I'm like, wait a minute. The only thing that's going to change is the sign. Why are you doing all that work again? And then they'll go, oh, yeah, yeah. And then I'll walk away and I'll come back and they'll still be over here going like this. I'm like, no. So they really have to use that rule if they figure it out, right? Because if you notice on those next few problems, it's the same numbers. The only thing that changed was the sign. And then hopefully they can see this connection between the patterns. So this first one would just be negative 322. The next one, negative 322. And then the last one would be positive 322. So you're reinforcing that pattern or that idea. But I'm telling you, it's just like the kid who you're like, when you're adding and it's 5 plus 4, you don't have to count the 5. You already know you have the 5, right? Just count the other ones. So it's the same type of idea. They'll get there. Everybody okay with that? All right. So on this one, here's a new one. It's the last one on your page, I think. So 25 times 32. Try this in a different way. Try this in a non-traditional way. All right, what brave soul wants to tell me this way? And hopefully we did something other than the area model. If you only did the area model, it's okay, right? But there are other methods we can use. I'm ready.
I can share.
Yes, go
I
for it.
don't know how to write on it. Do you want to just like write what I'm saying?
Yes.
Okay. I think it's called partial differences. I'm not sure if that's what this is called. Yeah. So I lined it up vertically, so 25 times 32. And then I did 2 times 5.
Okay.
And then got 10. Sorry, that's just the way that my brain was doing it.
Nope, you're good.
Order. And then 2 times 20, which is 40. And then 30 times 5, which is 150. And then 30 times 20, which is 600. And then I added them up.
Excellent.
And got 8.
Sorry, got what?
800.
Very nice.
Okay, I was like, wait, what?
Did anyone do it differently? Mackenzie, that was perfect. Did anyone do it differently? Think of even mental math. Did anyone just do it mentally?
I started to do it in the extended algorithm.
Yeah. Which is like this partial products, right?
Yeah.
Good. Excellent. Did anyone do anything else? So I did money. Does anyone think about money? So 25 really sounds like 25 cents to me. And so I was like, ooh, there's 4 quarters in a dollar, right? So how many dollars would I have if I had 25? And I was like, ooh, I'd have $8. So that must be 800. Did anyone else use money?
I used the base 10 representation.
Nice. Excellent. So almost like a picture. Did you do this where you had 20 and then 5?
Yeah, I did like
And
half a
then
box and then
yeah, and then you had 30 and 2. So then
Yeah.
you could fill these up.
Mhm.
Excellent. Do you see you guys have learned a lot more than you realize? Especially if you're practicing these, right? And then you can count them all up, right? What's interesting is these two are very closely related, right? 1, 2, 3, 4, 5, 6. There's our 600, right? And then you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's your 150. Here's your 40. And here's your 10. Do you see how those are connected? Yeah, it's weird because we don't make the connections unless we see them side by side. Very nice. Good. Okay, so then you saw the next 3 problems are very similar, right? 25 times negative 32, negative 25 times 32, and negative 25 times negative 32. So just being able to practice all of these, again, is really important. Don't let these skills that you're learning in the first half of the class go away for the second half of the class, because we're going to get knee deep into fractions really quickly. I don't know that we need to do that one. How about a division one? Do you want to do a division one? How would you do this? Divide this somehow. I don't care. A non-traditional way to divide. Try that one. Okay, anyone want to share this one? You guys are more nervous about the division? You still working on it?
I can go again.
Okay, I'm ready.
I just did the big 7, the scaffolding.
I love that method.
Yeah.
Okay.
And then I did 4 times 100.
Very nice. I think I wrote that backwards. Sorry. I don't know how they write it over here. Okay.
And then got 400. Was left with 164. And then did 4 times 20 for 80. Was left with 84. 4 times 20 again to get another 80. And then left with 4, and then just did 4 times 1. Then added them up for 141.
Nice. Excellent. Anyone else do it differently? This is the same problem we did with base 10 blocks the other day, I think. Seems familiar. That 141. I love the big 7. It's awesome. Okay, we can do you want to try a different one? Or you've had it with division? It's up to you guys. I don't care.
We could probably do another one.
Yeah. So 462 divided by 3. And you could use whatever method makes sense to you.
I have a question.
I'm ready.
It's like kind of it's related to this, but it's kind of off topic a little bit.
Yeah.
So let's say like on our exam, like when it comes to doing this section, are you gonna have any problems that say like we have to do multiplication and division like a certain way, or can we choose whatever way we would want to do them?
I don't remember specifically if I say that. I'm trying to remember. Let me look real quick. And I'll answer that. Anyone want to explain that while I look this up? Explain this division one. I'm looking at it right now, just in case you're wondering. So that one says solve the problem by any method. Show your work. Nope, so I don't have any specific where I say you have to do it a certain way.
Do you have to name the method that you used?
Some of them, yeah.
Okay.
All right, how'd you do this one? Anyone?
Can I try with the base 10 blocks?
Sure, with the base 10 blocks. So tell me what you have.
So I have 4 flat boxes and 6 long boxes and 2 units.
Okay.
And first, I will divide those 4 flat boxes into 3 groups. And then now I have 1 flat box remaining and 6 long boxes. I will decompose that 1 flat box to 10 long boxes. Now we have 16 long boxes, and if we divided them into 3 groups, we will get 4 long boxes in each group.
So those 4 are gone, those 4 are gone, and those 4 are gone. Is that it?
Yeah. And
Okay.
now we have, oh, actually 5. 5
Okay.
long boxes in each group. Yeah, now we have 6, 7, 6. Wait a minute. So now we have 1 more, right? 1 more.
Oh yeah, so I should have 1 long not colored in, right? Sorry.
Yeah.
I should have 1 of these still available. There you go.
And then we will decompose 1 of those long boxes to 10 unit boxes. And we have 12 unit boxes divided into 3 groups. We get 4 units in each group. So, and if we look at each boxes, we have 154.
Nice. So my answer is 154. Excellent. Good job trying a different strategy. It's good to practice these, right? Everybody okay? So I just want to talk a little bit about this. The difference between 6 squared, negative 6 squared, or the opposite of 6 squared is how I would read the middle one. And then negative 6 squared would be the last one. So does everybody know the difference between these? This one's 6 times 6, yes? This one is the opposite of 6 times 6. And this one is negative 6 times negative 6. So this is 6 squared. Oh, can't write. Or 6 to the second power, right? This is the opposite of 6 to the second power, or 6 squared. And this is negative 6 squared. Factor language, this is 2 factors of 6. This is 2 factors of negative 6. And this is the opposite of 2 factors of 6. So here, 6 to the second power, the opposite of 6 to the second power, and then negative 6 to the second power. What do these 3 equations equal?
36.
36.
This one's 36. How about this middle one?
Negative 36.
Negative 36.
Negative 36. And this last one?
36.
Positive 36.
Positive 36. Excellent. So it's just a reminder. Yeah.
Can you explain the middle one on why it's the opposite of 6? Like,
Yes.
wouldn't it be negative 6 times negative 6?
No, it's not. If they want this negative to be raised to this second power, they have to put it in parentheses. Otherwise, this negative does not belong to this 6. It says raise this base to the second power, now take the opposite of it. And that's what a lot of people missed in algebra. So that's really the opposite of 6 to the second power. If I wanted it to be negative 6 to the second power, I have to put it in parentheses.
So the exponent is only talking to the digit, not the signs?
Correct.
Okay.
Unless it's put in parentheses, then it's that whole thing raised to it.
Because then it's like grouping it together then?
Absolutely. You are absolutely correct.
If I was taught to put like an imaginary 1 behind the negative sign, would that still work, or is that not mathematically correct?
It still works, but it's a little bizarre. I don't like imaginary, right? I live in the real world, so I don't like imaginary unless I'm talking about imaginary numbers. But what your teacher was trying to show you was that if there was a negative 1 there, then you would see that exponents comes before multiplication. So order of operations would hold up. So if that's how people remember it, that's fine. Did that help?
Yeah, thank you.
Yeah. All right. So the only thing I had left was just some order of operations problems, which I know sounds super fun, but we're not going to do them because we're going to have to go, oh my gosh, look how many I had. I had so many fun ones. 1, 2, 3, 4, 5. Oh, that was so fun. I'm so sad we missed it. Maybe I'll make you do it in your groups on Monday. I know you have a lot of homework, but I just put, make sure you do that, completing your addition and subtraction. Your other homework is all done Monday night, so you don't have, as much as, and I gave you less, believe it or not, I really gave you less homework this week because I knew you had your midterm. So it might not have seemed like nothing to you, but it was. I'm going to put that back up in a minute. I'm going to put the exit ticket in the chat real quick. Maybe, if it will let me paste it. Darn it, this stupid thing. Sometimes I love my iPad, sometimes I hate my iPad. So there you go. It is what it is. Your exit ticket goes back to what we were talking about at the very beginning. So I want you to make sure you don't have to draw your pictures, but you are going to write out your steps. So sorry, I'll put the exit ticket in the chat in just a second as soon as I grab it. And then I'm expecting a lot of you today, right? I have a lot of midterms today and then the rest of them tomorrow. So make sure you show up on time. It usually does take me almost the whole time, depending. And then if we have any extra time at the end, I let you guys ask questions. So like if you have a question over one we didn't go over or a question about your Canvas part, that should be the exit ticket in the chat. At least I hope so. Otherwise, great job. And whoo, can you believe we're halfway done? I know it's a quick trip. And then I will see you Monday. Bye. Happy birthday, Anaka. Maybe her birthday's tomorrow. I feel like it's tomorrow. I can't remember. It was today. Good. Did you guys say happy birthday? You should have started it in the chat. We missed it now. Now we have to send her a message.
For homework that's due on Monday, we have the Frayer model and then the prime versus composite. The Frayer model says like we're supposed to work in groups.
Yeah, we're going to do that in class.
Okay,
Monday.
So we shouldn't do that one.
No, don't do that one until Monday. I mean, you can start it, but you would, you know, have to go over it in class.
And then what about the prime and composite? We could do that one.
Yeah, you can do that one if you want. The adding and subtracting integers homework says the 21st on Monday, right?
Yeah. Do we click on class time or office hours for
Class time.
class time? Okay.
Yeah, I just made it class time because that automatically records and office hours doesn't.
Okay.
And you guys are the only ones who have my class time link. My other class has my same office hours link and I don't want them in there.
Okay.
So yep, class time. Anybody else have questions? I'm hanging out here for a few more minutes.
Thank you. I'll see you later.
I'll see you at 4, right, Gabriella?
I have a question about the order of operations.
I'm ready.
So we use the GEMS one because the PEMDAS ones is confusing, right? Because it doesn't
Okay.
say
Yeah.
left, right? So when you are doing multiplying and dividing, you just go left to right, like it.
Correct.
Okay.
Yeah. So if multiplication comes first, you do that first. If division comes first, you do that first.
Okay.
Did
It's
you
just
want to go ahead?
It's just so weird because I've always done PEMDAS. So like when I was doing a problem earlier this week, I was using it and I got one answer. And then after you went over that, I redid it and I got a completely different answer. And I'm like, oh my God. So
Yeah.
I'm just wanting to make sure that it goes left to right because it was just so weird to me,
Yeah. So if we look at one of these, so for example, on this second one, on this 26 divided by 2 times 5, that one, if you followed PEMDAS, you might be likely to do 2 times 5 first.
Yeah.
But you don't want to because it's multiplication and division left to right. So this right here is what you do first. So you get 13 times 5 minus -3 times -4.
Okay.
Does that make sense?
Yes, it does. I just wanted to make sure I was.
Yeah, nope, you did right. And then like here, none of those are really multiplication and division, so you should be okay. So yeah.
Okay. All right.
Yep, you're
Yeah.
right. I know. Now you know why PEMDAS is confusing, right?
Yeah, it's weird.
Yep.
Okay. I'll see you tomorrow. Thank you.
Tomorrow. Amy, questions?
Oh, I'm sorry. I didn't realize I was the last one. I
No,
was
you're
just,
good.
so I'm doing the exit ticket and I understand how to do it, but I'm a little stuck on the part where you said, I know we add the 2 pairs because we didn't have, I think you said a negative or positive in the previous question you said. I was trying to look for it.
Okay, so tell me what the problem is. Just read me the problem that you're doing on your exit ticket. What is it?
So it is 3 minus parenthesis minus 2.
Oh, okay. So is that a -2? Read it again using the proper language of integers.
So it's 3 minus, is it the opposite of -2? No?
No, it's just 3 minus -2.
3 minus -2. Okay.
Okay. So we have, if you were going to model this, what would you model first? What would you put out?
So you model the minuend, which is 3 positives.
Okay. So you're going to put out 3 yellow chips, right?
Mm-hmm.
Okay. What are you trying to take away?
You're going to take away 2 negatives.
Do you have any negatives to take away? You have 3 yellow chips out. Do you have any red chips to take away? So nope. So you don't have, you just have 3 positive chips. You don't have any negative chips to take away. So you have to add, what are you going to add?
You have to add a pair.
You have to add 0 pairs.
Add 0. Add
Call them 0 pairs. So you're going to add 0 pairs until you have 2 negatives to take away.
Okay.
Oh my God.
And then what do you do?
And then once you have that, you take away 2 negatives.
Yep. And then what do you do?
Then your last step would be to add all the chips together that you have left.
Okay.
And then your answer should be 5.
Very nice.
And then, so I had a couple of quick questions,
Sure.
just on the worksheet from yesterday.
Okay.
So I was having a little bit of trouble with me and Sophia, because she was my partner yesterday. We were a little bit confused, like on the drawings part.
Uh-huh.
So these 2 correlated together, right? The first 2, they were both like one problem.
What number are you on?
I'm on number 3 on the first page.
Yeah, so all those pictures go together. That's one problem.
Okay, so all of that is one whole problem.
Mm-hmm. So what problem is it showing?
Okay, so I see the first is 8 and -3.
Okay, so what's the math problem?
So it's 8 plus parenthesis minus 3 parentheses.
Okay, so 8 plus -3, not minus, negative.
8 minus -3.
No, 8 plus -3.
-3. I'm sorry.
You keep saying -3.
Negative, yes.
Yeah.
And that gives you 5.
Oh, wait. So what's that next step? What's happening on that next step?
Can be arranged as, okay, so you have 3, 4, 5. So you have 5 positives on the left side.
Mm-hmm.
And then you have, it looks like they added zeros.
Did they add zeros?
0 pairs?
Did they add 0 pairs?
Yes.
I don't think so.
They have 3 positives and 3 negatives.
Yeah, but didn't they have those up above?
Uh-huh.
They still only have 8 positive chips, and they still have 3 negative chips. So I typed in the chat what they did. Okay, look in the chat. Do you agree with that?
Plus 3 minus 3. Yes, I do.
Well, in this case, they didn't add any 0 pairs. They just matched up their 3 positives with their 3 negatives because they know those have a value of 0.
Oh, okay, that makes sense. See, I was a little bit confused on that. And then so for the bottom portion, it would just be, that would be the final answer, which is 5. So they just kind of broke it down, if that makes sense.
They're showing you how they did their work. They had all their chips and they combined them because it was addition. And then they said, oh, these have a value of 0, so I really only have 5 left.
Ah, okay, that makes sense. Okay, so that would be the same thing for the other problem then, which I think I can figure out. Can you briefly go over the sweater scenario? I know I was kind of looking at it and it kind of makes sense. And it kind of does it, like on your slides.
Okay, so basically it's just, I mean, did you review the slides?
I did.
Because that's all it is. It's basically the difference between, let's say you paid with a check and you go back to the store and say you don't want the sweater. So they give you your check back. So in your check register, you get rid of that subtracting $50. So you're adding $50 to your account. Same thing is if they just credit your account, they add $50 to your account. It's just a matter of which way it's written.
Ah, okay, that makes sense. And let me see, I think I had one last question. One was a positive and one negative. I know I had one last question, but I gotta look for it. But that's it. Thank you.
Okay. Send me a message if you remember, right?
Okay, thank you.
Okay, no worries. See you at 7:30, right?
Yeah, see you.
Okay,
Thank you.
bye.
Bye.